Good morning, everyone. Let me introduce myself to you. My name is Iyavana Choprigad. I am from Computer Science and Engineering A&M ML branch. Today, I'm going to talk about conducting polymers. Contents: Introduction. Examples of conducting polymers: conditions to become conductive. Synthesis of different conducting polymers. Applications of conducting polymers. Introduction. The word polymer comes from the Greek words "poly", meaning many, and "mers", meaning parts. Polymer is formed by combining of small molecules. The individual small molecules from which polymer is formed is known as monomer. The process by which the monomer molecule are linked to form big polymer is called polymerization. Examples of polymers. Here are some examples of these polymers: ethylene vinyl acetate, polyethylene, polypropylene, polystyrene, polythiophene, polypyrrolene, etc. Conducting polymers. Conducting polymers are organic polymers that conduct electricity. Conducting polymers have an extended p orbital system through which electrons can be moved from one end to other end of the polymer. Some examples of conducting polymers are polyacetylene, polyvinylene, polypyrene, polyaniline, polythiophene, etc. Examples of conducting polymers. Here are some picture diagrams of the polymers. Mechanism in conducting polyacetylene. Polyacetylene shows both cis-trans isomerism and uncharged structures of polyacetylene. If cis structure begins to isomerize to trans geometry, a free radical is formed. This is a relatively stable entity, and the resulting defect in the chain is called a neutral soliton. A positive soliton can be created by controlled addition of an acceptor or redoping agent such as AsF3, Br2, I2, removes an electron and forms a result in the formation of carbocation or carbonium ion. A negative soliton can be created by treating the polymer with a donor or N-doping agent that adds E-N and results in the formation of carbon ion. Here is the structure of polyacetylene. All cis polyacetylene, which is copper colored, and all trans polyacetylene, which is silver colored. Mechanism in conducting polyaniline. Polyaniline is unique due to its ease of synthesis. Its solubility is selected organic solvents, environmental stability, and simple doping. Polyaniline becomes conducting when the moderately oxidizing states are protonated and charge carriers are generated. Number of E-minus have to added or removed from the insulating material to make it conducting. Here is the diagram of the aniline structure, mechanism of conducting polyaniline. Now we are going to talk about applications of conducting polymers. There are many applications for the conducting polymers, which are some of them are given below. Used as anti-static substances for photographic films, used as corrosion inhibitors, used in compact capacitors, used in transistors, used in light-emitting diodes, used in sensors, used in Solar cells used in display screen of mobile and mini format division screens also. Here are more examples of the polymers. Factors that affect the conductivity. Here are some of the factors that affect the conductivity. Density of the charge carriers, their mobility, the direction, presence of doping materials, and temperature. Now we can sum up all the points we have discussed. Conjugated polymer or semiconductor material, while doped polymers or conductors. The conductivity of the conductive polymers decreases with falling temperature in contrast to the conductivities of typical metals, example silver, which increases with temperature. Today, conductive polymer being developed for many uses. Thank you everyone for giving me this wonderful opportunity. Have a nice day ahead.